In this video, we will be solving questions 3 and 4 out of problem set 1 from Calculus by Munem and Foulis. And I actually had both the yellow and the blue cover editions when I was in college. So question 3 is, use the rules of inequalities to show that 3 over 28 is less than 25 over 233. So to solve both questions 3 and 4, we're going to use the following property for inequalities, and that's the division rule, where if A is less than B and C is greater than 0, and that's an important thing to remember, then A over C is less than B over C. So to solve question 3, we start off with the statement 699 is less than 700. And what we're going to do is we're going to divide first by 28, which gives us 699 divided by 28 is less than 700 divided by 28. And the right-hand side simplifies simply to 25 because the 28 and 700 have a common factor of 28. Then, using the principle again, we divide both sides by 233, and here in the right-hand side, what ends up happening is the 699 and 233 cancel out to just simply have 3 over 28 is less than 25 over 233, which is what was asked to be proven. So that's the answer to question 3. Question 4 says, show that if 0 is less than x, which is less than y, then 1 over x is greater than 1 over y. So, to do this, here we are. First, we take note that because of the fact that the 0 was explicitly included, that didn't just simply say x is less than y, this is important because that means that both x and y are positive numbers, which just allows us to use the rule that we referenced in the earlier slide here. So, we're going to take the expression as is, 0 is less than x is less than y, and divide it first by x, which gives us 0 over x is less than x over x, which is less than y over x. And doing some simplification there, obviously 0 over x turns to 0 and x over x turns to 1, we get 0 is less than 1 is less than y over x. Now we take that expression and divide throughout by y to give us 0 over y is less than 1 over y is less than y over xy. And again, canceling a few things out, we end up with 0 is less than 1 over y, which is less than 1 over x, and that's what was asked to be proven in the question. And so we're done.